Hello everybody. This is my second video on the series where I am creating a planet and imagining what it could be like. So if you haven't seen the first video, go check it out. And with that out of the way, let's begin. So, as you may or may not remember, depending on whether you saw the original video or not, the first period was Kalaka and it spanned over around 1.85 billion years. And meanwhile the period was ending, life started to slowly adopt stranger and stranger forms and behaviors, to diversify. The second period, the period after that, we're going to call it Oostaka. Unlike the previous one, Kalaka, this one does not necessarily have an earthly equivalent. During this period, while yes, life was starting to get a little more diverse, such an enormous explosion of diversity like see in the Cambrian period would not come until later down the line. Another interesting fact about this period is that the Moon, which was likely just a bigger than average asteroid, got away from Rustaria's gravitational pull during this exact period, and hence why the planet doesn't have any celestial objects accompanying it wherever it goes to this day. But that's not the only thing. Another really interesting and intriguing fact about this period is that Mokia, an organism that we previously saw in my other video and is the ancestor of what we would typically call plant life on this planet, some millions of years after the Oostaka period had just begun started to grow even larger, with it being able to be seen by our naked eye, growing up to around 0.85 centimeters in size, but at most being able to reach the astonishing 5 centimeters for that time. Not only that, but some fossils indicate that these organisms were starting to go on land, though it would have most likely been just the most moist areas, just around the coasts of the continents and islands. And not only the fact that their transition from water to land had just begun, and the fact that they grew much larger than the rest of the organisms present at that time, but also the fact that more and more oxygen was being produced on this planet meant that it was getting warmer and warmer. But sadly, all good things must come to an end. The reign of these organisms on land is up to debate, but most data seems to suggest that these plants had lived for up to 20 to 200 million years until they suddenly vanished. It's not 100% clear why that happened, but most likely, a supernova hit the planet and with that most, if not all of the atmosphere disappeared. Other two things that happened because of that, was that not only much of the evaporate into space, but it would have also caused the departure of Rustaria's moon-like object. And lastly, luckily some of these primordial plants just didn't transition from water to land, and would serve as the ancestor of the current plants on this planet. Though, the second conquest of the land would come up much later down the history of this planet, but enough with these plants. What animal life could have been found in the oceans during this period? Well, do you remember Iteria and Barbonsae, those cousins in the evolutionary tree that also looked really similarly? Well, most likely, what happened during the Oostaka period is that Iteria outcompeted Barbonsae in the food department, causing all, or at least most of the Barbonsaes to starve to death. It's unclear whether they died before or during the mass extinction caused by the supernova, but they most likely left absolutely no descendants alive up to today. But what happened to Iteria and its descendants? Well, long story short, it managed to diversify and occupy many niches it previously didn't hold. I'm about to show them in a second, but before that, I want to also say that other organisms also managed to flourish, at least if you can call it that, during the Oostaka period. Now, this is Palfka, a descendant of Iteria, that went on to slowly evolve into what we would typically call an arthropod, specifically a marine one. It has adapted due to pressure from other organisms to develop this exoskeleton, which would lead them and their descendants towards easier lives. This is one of Palfka's descendants, Dolphuit. It continued to adapt a harder and harder exoskeleton, and as you can see, it has also adapted to a crawling lifestyle. It has now surprisingly evolved eyes, and evidence shows that even before the mass extinction, Some animals were able to go on land, though most likely it hadn't evolved lungs yet. It probably stored some water around its gills or in a separate organ. They went on land as some sort of a mating ritual. And lastly of this lineage I am going to show today is Bartska. It split off from Dolphuid right when leg-like appendages started to appear beneath their bodies, and has made even more use of them. Of course, most of its legs, that is, 6 of them, are used like legs. But it has also got 2 front limbs, which have surprisingly developed 2 or 3 finger-like structures just like what the crab has. The number of these vary between fossils, with those that have only 2 fingers being dated earlier than the other ones. An interesting fact about the Bartska is that there have been multiple fossils of it where there is a blood-like fossilized liquid close and sometimes overlapping with the individual. This leads to the possibility that not only it, but also Dolphuid also had this blood, and possibly even Palfka and its other descendants. But what about the other descendants of Iteria? Well, one of these is a swimmer called Simu. As you can see, it has got 2 antennas, which were most likely used as a method of echolocation, as they didn't have eyes yet. An organism that evolved from Iteria alongside Simu is Opertuk. It is the founding organism of yet another one of the 3 main Iterian lineages. As you can see in this picture, Opertuk had an early development of a mouth-like structure, which were supported by some primitive type of bone-like structures. It was also the first one to develop a 2-sided tail, just like what we see in modern sharks and other fish today on Earth. Other organisms from this time period are ones such as Galgatka, Borvansa, Chitku, Ocranum, Gahart, Paisku, Valharn, Urkatsa, Didko, Kairava, Monstracantium, Mochium terrestrus, Mochiuma, Fastharna, Gilabi, Palatrui, Uniui, Barsina, Wazer, etc. Now, I'm going to show you how the planet looked during the Ooze-Taken period, which lasted for more than 900 million years. Thanks for watching.
Exomologiste toi Kyrios, diagathos, alleluia, odis ton neona, o eleos, alleluia.